Hi everyone, I am Sampreety Swarnakar from ECE department and welcome to my YouTube presentation. Today I am going to take you through an important topic in signals and systems, classify of signals. We will start with what signals actually are, why we classify them and then explore different categories one by one. So let's jump in it. Introduction to signals. A signal is basically a physical quantity that carries information like voltage, current, sound, temperature, or even images. We can represent a signal as either a continuous time signal or a discrete time signal. In communication system, signals are used to transmit information from a source to a destination. Significance of classifying signal. Why do we classify signals? Well, classification helps us in proper analysis, better understanding and easier mathematical modeling of signals. It also assists in designing efficient communication and control system. In selecting suitable signal processing methods. Deterministic and non-deterministic signal. First classification, deterministic signal and non-deterministic signal. A deterministic signal can be exactly described by a mathematical equation and its value can be predicted at any time. Example, a pure sine wave. A non-deterministic signal or random signal cannot be predicted exactly like noise in communication system. Periodic and non-periodic signals. Next, periodic signals repeat their pattern over a fixed interval of time. Example, AC means voltage. Non-periodic signals do not repeat their pattern like clapping, sounds or speech. Symmetric and anti-symmetric signals. A signal is symmetric if it is mirrored around the vertical axis. Basically, it looks the same on both sides of the origin. And anti-symmetric signals has a similar shape but inverted in sign on one side. Energy and power signals. An energy signal has finite energy but zero average power. A power signal has finite average power but infinite energy. For example, a pulse of finite duration is an energy signal, whereas a continuous sine wave is power signal. Causal and non-causal signals. A causal signal exists only for present and future times, meaning it does not depend on future values. Example, electrical signals after a switch is turned on. A non-causal signal exists for negative time as well or depends on future values. Example, pre-recorded signals played backwards. So, to conclude, signal classification is important for understanding and processing signal effectively in engineering applications. It helps us choose the right tools and methods for communication, control and analysis. Thank you for watching.